Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Efficient Navigation in Mobile Robots using fuzzy-driven CH selection and CH chaining-based relaying. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, today I'm here to present you one of the recent research area that we are working on and have successfully completed. This is for the mobile robot swarm to enhance their network stability for the data collection. Welcome to TechPacks Research and Innovation. Before moving further to this video, let's talk about that what we will cover into this video. So in this video, initially we will discuss about what application areas does it support, what research areas can be further extended. Along with that, whatever the code we have designed, how to execute that code, which files we need to execute, and what are the software requirements for that. Along with that, we will discuss that what exactly the current systems are, what problems we have identified, and what proposed methodology we have covered. And finally, whatever the experimental outcomes were there after the simulations and findings will be discussed. So let's discuss about the application areas. As I told you that this application is related to the mobile networks, so it is also termed as manets. So the manets are a unique domain specifically where the sensors or the device is moving or the user is moving, especially for the it can be drones, it can be the vehicles and many other sensors, right? So here a few of the applications are there, like for the disaster relief where the persons are moving or vehicles are moving, especially like ambulances or relief parties and many other outdoor meetings where in the vehicle whether the connectivity of the sensors is there, battlefield communication, right? Multi-purpose game through the Bluetooth and many others. The brief of the application areas are like smart healthcare for the smart cities, for the transportation purpose, emergency services, entertainment, and many others. So you can read more in detail about it. Now let's talk that what code and how we have to run it. The folder that we are going to provide will have the code folder. You just need to click this. Along with that, you must have the MATLAB software with you. The MATLAB software that you need to use is either 2018 or the upper version. Here I am using R 2019A, but make sure the MATLAB should be a full version. It should not be a trial one, right? Because certain libraries are there that need to be there in the MATLAB to execute the whole code. So how you need to run this code? You just go to the folder where the whole code is placed and you just need to copy the path of the folder. Then go to the MATLAB and here in this particular bar you just need to paste it and press enter, and you can see the whole files whatever were there in the folder, those are there. Now the main file that you need to run is the main code. Here is the main code, and there are different scenarios, those are considered for the simulation of this particular work. So those are also there. So let's talk about that how to execute it. You just need to select the file and click on the run button. When you click on the run button, it will execute the whole code. You can see that it is asking for the speed of the node. Let's say I'm entering 10 km per hour or 20 km per hour. It totally depends upon the value you want to enter. When you press enter, it will start simulation. So as the simulation is at the back end, let's talk about that what exactly the current systems were. So the base paper that we were following for this simulation is the leech relay of the cache in the mobile robot swarm. So in this, what they have done, they have given a strategy for selecting the best cluster heads and the whole scenario is of the mobility. So cluster head selection is done on the basis of the energy. So you can see the selects the cluster head to balance the energy consumption by the relative energy levels. So after implementing the whole scenario and the energy models, they are implementing the base of the leech protocol, which is a very previous one, but because it's the mobility one, so obviously certain scenarios will be there. So you can see they have given all the scenarios that how it get communicate. You can read this paper, and finally they have done the analysis in certain conditions where you can see they have changed the base station speed and calculated the lifetime and packet delivery ratio for the different algorithms. Then they have changed the node speed in the kilometer per hour. As you can see, as I was running the code, it was asking for the node speed, so that is why we have given it as this dynamic model. And finally the network size, so it can be 800 by 800, 900 by 900, and so on. So all these scenarios has been analyzed and compared that which technique is giving the better results. So PDR must be higher, lifetime must be higher. So this is basically the parameters that we are using. So what exactly we have done? So the in the proposed strategy, we have identified the problem that the cluster head selection is not only dependent on the energy. There are certain other factors on which the decision can be made. So we have extended the parameters. Along with that, we have implemented one decision model that is basically on the fuzzy basis, which is evaluating those parameters and selecting the best cluster head. Finally, for the routing purpose, we are not directing. In most of the scenarios, the node is directly communicating to cluster and cluster is directly communicating to sink. But this is an old strategy. The further modifications can be done because as it is a mobile one, right? So for the mobility, the communication must be like that, that it can successfully transfer the data, because of sometimes communication among the ch cluster head to the sink can be more at the distance. So that's why we are forming a chain among the nodes to communicate to the sink. So as you can see, the number of rounds are running. So what we have done, we have initially created the fuzzy system. So fuzzy is basically the model. I just need to stop this code. I'm just press Control C to close this. Let's see that what exactly the code has. So this is the fuzzy system that we have designed. In this, we are taking three different parameters, that is distance for the communication, connection request within the cluster, and the residual energy of the node to select the node, which gives us the probability between 0 to 1. This fuzzy system is initially called and saved in the terms of the ch deck.fizz. Fizz is the fuzzy file. So other than that, we have given this scenario for the base as per the base paper where they have evaluated the results. So this is the scenario. We just need to enter the speed, and then random wave model is used for the mobility model, where we need to define the limits of the area, how much speed interval will be there, the pause time, walk time, degrees of the movement, how many nodes will be there, how many seconds it will move. All this has been given by giving the mobility model for the speed and sync. So different scenarios, what we were talking easily earlier. So by this, in every of the scenario, the nodes are generating their parameters. Those parameters are like distance, then energy and connection in the tentative cluster heads. They are evaluating these factors and getting the probability, and the probability with the maximum value is selected as a cluster head. Then the communication among them has been done, where the energy model equations has been used. And finally, in order to transfer the data from cluster head to sink, what we have done, we are calculating the cluster heads distance from the sink and order them as per the weightage, and on the weightage based we are following the shortest distance chain forming to the sink. So this is how it is doing the communication. And finally, PDR, delay, energy, all these factors have been calculated in order to do the comparison. So this is the whole code, and different scenarios has been done. As you can see, this was the fuzzy system that we have designed. This is the code, and these are the scenarios. We have done the whole code in the different files only by changing that nodes, that area, the speeds and all. So this is the code, like this is for the changing the node speed. Whole code is same, only the speed of the node is changing, right? This is the scenario where base station speed is changing. So here you can see the node speed is fixed and base station speed is gonna change. then the area changing. Here only the area is getting from the user, rest all the scenario is static as per the base paper. And finally, after running all the codes, we have saved all the results. Here you can see for the area 800, 900, 1000, 1100, 1200. This is for the speed of the node speed. So we have saved it. If you want to run it, it will run and generate the new results. We have saved by using the commands like save, and whatever the results were there, we have saved those. So finally, let's see that what exactly the results are. So the results, all results are compared in a separate file because these are the different scenarios and we need to show in the one single file. So you just need to run the comp result and make sure all these files must be there in the folder. So when you will run it, it will generate the results in terms of different parameters. Those were already there in the base paper in order to show that our proposed system is better in terms of the parameters they are following. So you can see the graphical representation for different factors will be there. The factors that we are analyzing are, let's see, it will take few seconds. So you can see we have 8 different graphs. The first one is the number of packets with respect to packet delivery ratio with respect to number of packets, that how many packets has been sent and what is the packet delivery ratio for the different algorithms. So you can see the pink curve which is of proposed one, so it is higher with respect to the all other methods, so our system is better in terms of PDR. Next is the delay with respect by changing the packets, then packet delivery ratio by changing the speed of the base station, then lifetime by changing the base station speed, packet delivery ratio with the node speed variation, lifetime with respect to node speed variation. This is PDR with respect to network size, and finally the lifetime with respect to network size. In all the scenarios you can see the PDR is higher, the pink curve is of ours. So in all scenarios our system is showing the better results, which shows that the improvement that we have suggested is effective. So further modifications are still possible because here the fuzzy system is used and further routing and many other scenarios can be updated. So for that you can contact us directly and can get the details. Thanks for watching the video. Thank you.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.